Okay, guys, I have gotten really behind on the videos and I apologize for that. So, we're going to start our videos on hyperbolas. Okay, so hyperbolas have lots of parts. Um, and their parts have slightly different names. We have what we call a transverse axis instead of a major axis. Uh, a conjugate axis instead of a minor axis. It's just different. So what we're going to do is we're actually going to just jump right into it. So I'm going to do two hyperbolas for you. First one I'm going to do is I'm going to do one that is centered at 0, 0. And the next one I'm going to do is going to be not centered at 0, 0. I think if I talk you through it, it might go a little bit better than if I just kind of, do it the other way. All right, let's look at our first example. Okay, so our first example is you'll notice that there is an x that is first. With a hyperbola, it's all about who goes first. All right, so if my x is first, my branches or the graph of the hyperbola is going to be side to side. So I find it helpful to actually kind of draw kind of a rough draft of what my final graph should look like. That way, if it doesn't look like that, if I get lost in the graphing, then I can go and fix it. Okay. Now, this particular hyperbola is going to have a center at 0, 0. So let's go ahead and write that down. Okay. Now, since the branches are left right, a squared is 9. And that means A is 3. Now, since it's left right, that means that you're going to count 3 from the center in the left hand and right hand direction. Okay, all right. Then B, that's the second one. So B squared is 25. All right, and that means B is 5. So we're going to count 5 from the center up and down because it's beneath the Y. Okay, so I'm going to go ahead and start graphing. Okay. So here, whoops, I don't want that to be red. All right, whoops. Well, that's kind of off, isn't it? All right, let's draw that again. I want it nice and centered on my graph. It's going to make life easier the neater that I am. Okay, here we go. So first thing I'm going to do is I'm going to graph my center. And I'm literally just going to count out A and B. So I'm going to go right 3, left 3, up 5, down 5. Okay, so you're going to use these 4 points to make a rectangle. All right, now the next thing we're going to do is we're actually going to draw in some asymptotes. The asymptotes are formed by the rectangles. You're going to use your rectangle as a guide to make your asymptotes. You're basically drawing the diagonals of the rectangle. Okay. All right, so there are your asymptotes. And what I'm going to do is I'm going to write the equation. Now, there is a formula for finding the asymptotes. We will talk about that formula later. It's more helpful when you have a hyperbola that is not centered at 0, 0. Okay, so this one, we're going to go with the positive slope. We're going to go up 5 over 3 is my slope, and we have a y-intercept of 0. Please note I am using the form y equals mx plus b. Okay, for this one. We're going to use another form for a line when we get to not centered at 0, 0. Okay, and then negative 5/3 x. Okay, now what we're going to do is we're going to remember that my hyperbola goes side to side, and I'm going to use the asymptotes and the vertices, okay, of the hyperbola help me graph. The vertices of the hyperbola are these points right here. Right there. Okay, here we go. All right, so that's your hyperbola. Okay, now notice that I haven't graphed focus or foci. I haven't graphed directrix or anything like that yet. So what we're going to do is we're just going to start labeling the parts that we have right now, and then we'll worry about foci and directrix in a bit. Okay, so for this hyperbola, my vertices are going to be here and here because we want the vertices to be part of the hyperbola. So that's going to be negative 3 and 0, 3 and 0. Covertices are opposite of that. So they're going to be the point 0, 5 and the point 0, negative 5. Okay, the transverse axis always goes with your vertices. Okay, so it's going to be a horizontal line right here. All right, notice the distance or the kind of the width of the parabola from the vertices is 6, which is double A. Okay, the conjugate axes goes with your covertices. Okay, all right, now let's talk foci and directrix. Okay, so foci are going to be C units away from the center along the transverse axis. Okay, now the formula is a little bit different from the ellipse, okay? So C squared is going to be equal to A squared plus B squared. So looks almost exactly like Pythagoras' theorem. So it's going to be 9 plus 25, and then we're going to take the square root. Okay, so that's going to give me 34. Using my calculator, I get 5.8. Okay, so if my vertices were at 3, I'm going to count 5.8 from my center. So that's 4, 5, 5.8 foci. 3, 4, 5, 5.8 foci. Okay, so my foci are located you could say radical 34, 0, comma, negative radical 34, 0, or you can use 5.8, okay? Kind of just depends on what the problem requires. Okay, now let's talk about directrices. Okay, so the directrix is going to be perpendicular to your transverse axis. Okay, and we're going to use the since it's perpendicular to that transverse axis, the formulas is going to be, for this particular hyperbola, it's going to be x equals d. Okay, now how we find that is we use this formula d a squared over c. Okay, now be careful with this formula. It's very easy to get confused. This is the distance from the center to the directrix. Okay, remember there's two of them, not just one. And we intersect the transverse axis in a perpendicular manner. Okay? All right. So RA, remember, was 9. Or a squared was 9. RC is 5.8. Or square root 34. So the D is 1.5. So my directrix is going to be 1.5 units away. From the center. Okay. So if the center is here at 0, 0, then let's zoom in a little bit so you can see. We're going to count 1.5 in either direction, making sure that we're parallel to that transverse axis. Let's see if I can get another color going here. Let's do that color. Okay. So, whoops. There we go. All right, 1.5. And there's your directrix. Okay. So let's add some information on our list. Okay. So our directrix is x is equal to 1.5 and x is equal to negative 1.5. And remember that is perpendicular, forming a 90-degree angle with the transverse axis. Okay. So as you can see, there's a lot of stuff going on here. Okay. So for the next video, what we're going to do is we're going to do one that's not centered at the origin. Okay. Make it a little bit tougher. Okay. And then we'll do more videos on these as we go along. Okay. All right. Thank you for watching, and I hope that was helpful.